Hello and welcome back to Saxon Math. This is lesson 77, Finding Unstated Information in Fraction Problems. Often fractional parts statements contain more information than what is directly stated. Consider this fractional parts statement. 3/4 of the 28 students in the class are boys. This sentence directly states information about the number of boys in the class. It also indirectly states information about the number of girls in the class. In this lesson, we'll practice finding several pieces of information from fractional parts statements. So in example 1, diagramming this statement, 3/4 of the 28 students in the class are boys. How many parts is this class divided? We're going to answer how many students are in each part, how many parts are boys, how many boys are in the class, how many parts are girls, and how many girls are in the class. So in order to start this, we can look at this first question again. Into how many parts is the class divided? Well, it has a fraction here, 3/4 of the students. If you guys remember, this usually means times in math. The 28 students are boys. But how many parts is the class divided? Well, 3/4 tells us that there are 4 parts that it's divided into. How many students are in each part? Well, if you have something that contains 28 students, so whatever this class is, and it holds 28 students, and it's split into 4 equal parts. Each one of those parts is 28 divided by 4, which is 7. So each one of those parts is going to contain 7 students. How many parts are boys? Well, it says 3/4 are boys. So 3 of the 4, notice that this represents 3 out of the 4. There's 1, 2, 3 of those parts. 3/4 represents the number 21 because 7 times 3 is 21. So how many parts are boys? 21 of those parts would be boys. How many parts are boys? I need to go backtrack. That helps us answer letter D there. So instead of saying how many parts are boys, I would want to say 3 of those parts because it was 3 out of the 4 parts. The total is 4 parts for 28 students. 3 of those parts are boys, and that gives us the number of boys in the class, 21 boys, because each one of those parts, this is one part, second part, third part, each one of those having 7 makes it 7 times 3, which equals 21. How many parts are girls? Well, the girls would be represented right here. This would be the number of girls. This would be 1 out of 4, which equals 7, and that represents the number of girls in this class. So how many parts are girls? Only one of those parts, because it is one part of the total. Remember, it was 3/4. So 3 out of the 4 were boys, 1 out of the 4 would be girls. How many girls are in the class? That would mean 7 girls are represented using that diagram. So you just want to start with the diagram, and here's the same diagram, and they just did the reverse order. They did girls here, and they did boys in these 3 parts. So 1/4 represents girls, 3/4 represents the boys, and you can see again the number of girls is 7, and the number of boys would be 21. All right, let's look at another example. There are 30 marbles in a bag. If one marble is drawn from the bag, the probability of drawing red is 2/5. how many marbles are red? So again, if you start with 30 marbles in the bag, you would want to split that into 5 equal parts. So because it says there's 30 marbles in the bag, one of those, the probability of them being drawn is going to be 2 out of 5. If one marble is drawn from the bag, the probability of drawing red is 2 out of 5. So the probability of drawing 2 out of 5 for the 30 marbles being red means you have to take the 2 times 30, which equals 12. So that means there are 12 red marbles, because 2/5 times 30 over 1 is the same as, well, I can see this would cancel, this would cancel. That'd be 2 times 6, which equals 12 over 1. So 12 red marbles if the probability is 2/5. If there are 30 marbles and the probability of drawing a red is 2/5. All right. In letter B, it says how many marbles are not red. So if 12 of them are red, now you just need to understand that in that one you're going to have to take the 30 minus the 12 to find out how many are not red. So in that case, if 12 of them are red and you subtract that, you end up with 18 for the marbles that are not red. And the probability of drawing a not red marble would then be 18 out of 30, which reduces to 3/5, because 18 over 30, both of these are divisible by, looks like they're both going to be divisible by 3 for sure. And this would end up being, in this case, that would be 6, and then that'd be 10. This would be divisible. They're both going to be equal to 2 in this case. So that would be 3/5. So I'd end up with 3/5 for the probability of drawing a not red marble. So anything other than red. It doesn't say what the other colors are, but we do know that 12 of the marbles are red. We don't know what the other colors are, but we know that 18 of them are not red. And then it asks, the complement of drawing a red marble is drawing a not red marble. What's the probability of drawing a not red marble? So that would have been 3/5. That's what we understood there, because if you had the 2/5 plus 3/5, that equals 5/5, and that equals 1 whole. So you can see these two are complements to each other. They complement each other because when you add them together, they add up to 1. What is the sum of the probabilities of drawing red and drawing not red? There it is. I answered it already. When you add the sum of the probabilities of drawing red and drawing not red, you get 5 over 5, which is the same as 1. The sum of the probabilities and its event, which are its complement, equal 1. All right, let's try another one here. So this is your practice set. I'd like you to answer these questions. Letter A. First of all, I'll start off by diagramming this for you. If we have 3/8 of the 40 little engines that could climb the hill, we're going to answer some questions using the diagram. So let's just break it down. I see that I'm going to need 8 equal boxes. I'm going to just use a rectangle like this. So this means 40 little engines. And then each of these needs to be split up into 8 equal boxes. So 1, 2, 3, 4, 5, 6, 7, 8. And then I have each of those will represent how much? Well, for letter A, it says into how many parts is the group divided? It's 8 parts for this one. I first answered it because it says eighths. Letter B, how many engines were in each part? So if you take 40 divided by 8, you know the answer to that. That would be 5 in each one of those parts. So that's letter B. Letter C, how many parts could climb the hill? So it says 3 out of the 8 could climb the hill. So that's these right here. 3/8 represents a number. It says, so question C is how many parts could climb the hill? 3 parts. Letter D, how many engines could climb the hill? So how many actual engines is 3/8 of 40? Well, if you count them up, you got 5, 10, 15 right there. So that means that's the number that could climb the hill. Letter E, how many parts could not climb the hill? So the other parts would be all of these others that represent the ones that cannot climb the hill. So we've got 1, 2, 3, 4, 5 parts could not climb the hill. And then letter F, how many engines could not climb the hill? So if it's 4 out of the 8 parts, which is really ends up being, 5 out of the 8 parts. If 5 out of the 8 parts could not climb the hill, we just take 5 times 5, which equals 25. So 25 engines could not climb the hill. All right, let's try another one. Read the statement and then answer the questions that follow. The face of a spinner is divided into 12 equal sectors. The probability of spinning red on one spin is 1/4. So if you have a spinner, let's say it's just a circle and it has 12 equal parts. There's 4 equal parts. Let's see if I can make this work. We have 1, 2, 3, 4, 5, 6. That didn't quite work out, right? So we got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Not drawn to scale, obviously. So if I have 12 equal sectors, if I was a machine and I could do that equally, they would all be equal. But there are 12 parts to this. The probability of spinning red on one spin is 1/4. How many sectors have to be red if the probability is 1/4? So I'm just looking at this as a picture, but it says that the probability is 1/4 for it to be red. That would mean that I need an equivalent fraction with a denominator of 12 to understand what that numerator would be for the number of parts or how many sectors are going to be red. So for letter G, I need to see that 4 times 3 equals 12, 3 times 1 equals that. So I'd have to have 3 sectors. 3 of the sectors would have to be red. Letter H, how many sectors are not red? So if 3 of the sectors are red, and I know that there are 12 equal parts to this spinner, all I need to do is take 12 minus 3 to find the number that are not red, which would be 9. So for letter H, it would be 9. And then letter I, what is the probability of spinning not red in one spin? Remember, red was 1/4, so what would be the complement, or what would be the thing that you would have to add to 1/4 to get one whole? 3/4 would be the answer because 4/4 is the same as 1 whole. So 3/4 is going to be the probability of not red if the probability of red was 1/4. And letter J, what is the sum of the probabilities of spinning red and not red, and how are the events related? So here's the answer to that. Letter J, the sum would be 1, and the answer to that is they are complements. Or complementary. Spinning red and not red are complementary events. So the sum would be 1 and they're complementary. All right, that's it for today. If you have any questions, don't hesitate to ask, and make sure you do problems 1 through 30 in your written practice so that you keep up on the previous lessons that we've reviewed. All right, have a great night.